Hello everyone, welcome back to Advent of Code 2024. As you can see, day 9 has just begun, so we could start. But I actually have a couple of things from yesterday, improvements from yesterday's solution that when I make them, I do like to show them off at the beginning of the video. I'll show them off, give you a tour, show you what you missed. So let's see. I just did two little things. We had day 8 part 2. First thing was, I realized, so I had been computing the antinodes in a way that made sense for part 1, but when I refactored out for part 2, I missed an opportunity to simplify in a way. So previously, I was collecting all of the distinct pairs of A and B by, collecting all the pairs and then keeping only the ones where A is greater than B. So we never get, we don't get AB and BA, we just get AB. And that way, I was saying, well, let's extend in the AB direction and then extend in the BA direction. But it's actually much simpler to just get the pairs, to get the pair AB and the pair AB both independently. Because then I can just say, I can just call take while on that once. I don't have to do all these gymnastics to avoid getting duplicate pairs when, I actually do want to compute the path from A through B and the path from B through A in both part 1 and part 2, really. When there were exactly 2, it kind of made sense for just part 1 to be like, okay, for each pair of nodes, here's the 2 antinodes. But when for each of them, I'm now extending out a certain amount in each direction, I realize it makes sense to just go ahead and get the duplicate, get both transpositions of each pair. And then I've written this label grid function enough times. I'd like it to be available as a thing I can copy and paste next time I need a grid problem. So it just takes a string and gives you back a v2 of its bounds and labels each character with the position it was at. So if I need another grid, probably I can just use this label grid and then do something with the already labeled grid. We'll see. So that's all. On to day 9. Disk Fragmenter. Not defragmenter, Fragmenter. Another push of the button leaves you in the familiar hallways of some friendly amphipods. What on earth is an amphipod? Is that from a previous year? It is. 2021, day 23, which... I didn't do this one, did I? No. That's why it's not familiar. Okay. Good thing you each somehow got your own personal mini-submarine. The historians jet away in search of the chief, mostly by driving directly into walls. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows you the disk map, your puzzle input, he's already generated. For example, okay. The disk map uses a dense format to represent the layout of files in free space on the disk. The digits alternate between indicating the length of a file and the length of free space. Okay, a 1-block file, 2 blocks of empty, 3-block file, 4 blocks of empty, 5 blocks. Got it. Yep. 3 9-block files with no free space between them. Okay. Each file on disk also has an ID number based on the order of the files as they appear before they are rearranged, starting with 0. So 125 has a 1-block file with ID 0. Okay. Then 2 empty spaces. And then a 3-block file I labeled 1. Okay. Sure. The amphipod would like to move file blocks one at a time from the end. Okay, so when you say file blocks, you're taking this. It's weird because this is like a single file, isn't it? It is, but okay. Because you're moving this block first to here. Isn't your file going to be backwards at the end? And then you're going to move this one here? Weird, okay. Yep, fine. The final step of this file compacting process is to update the file system checksum. Add the result of multiplying each of these blocks' position. What does this mean? The leftmost block is position 0. Multiplying it by the file ID number it contains. So the first file, which will be ID 0, won't actually contribute anything, I guess. Yeah, 0 times 0, 1 times 0, and then 2 times 9. Got it? The block contains free space, skip it. Well, I mean, if the block contains free space, we'll be done. We don't have to skip it. We can just stop, because that only happens at the end of the disk after we're done rearranging stuff. Okay. So we could just kind of do this. We could actually model the blocks, right? And like move them one at a time in this process where we go like from this line, from this first state to this second state, and then the third one. Which is totally possible and fine if that's what you want to do. But you, at least for part 1, you don't really have to do this, right? You could very easily hang on. Right, okay, so the 9s do go to the, okay, yeah. So you could just have like a list of lengths to represent this, right? Which is what the input is, really. But it also tells us how much blank space there is. Oh, wait, hang on. Oh, no, we're not actually necessarily moving entire... Right. We're not moving files as a whole because, like, this file 8 starts moving before this one and ends moving after it. Right. If there were enough blank space in between each group of files, we could say just grab file 9, put it over here in between 0 and 1, and then grab file 8 and put it in between 1 and 2 or something like that. And we're not just putting them all at the front, like put file 9 first, then file 8, then file 7, and finally put 0 at the end. Right, so we kind of do have to think about blocks, I think. There's not some cute trick involving just the numbers. So the first thing that occurred to me here, I don't think is what I should actually use, but I thought of zippers. A zipper is a functional... I mean, it's not related to zipping lists. It's a different kind of zip. It's a functional idea for, like, kind of a cursor through a data structure. Because it's inefficient. Like, if you have a linked list, for example, it's inefficient to edit the last element. Because if the list is immutable, to edit the last element, you have to replace the one before it also with a link to the new last element, and then the one before that with a link to the new last second element, and so on. And so zippers are a way to do this more efficiently by maintaining a cursor inside of the data structure. And so I thought, well, we might like have a zipper of the file system and step through it one at a time and replace each thing with, you know, and have another cursor over here coming this way. But I don't think something quite that fancy is needed. I think what we can do is just have something that is admittedly a little bit zipper-like, but we have a function that produces a list representing the final disk contents, which it does by starting at the left side of the list, and if it sees a block there, a non-empty block, it just emits that, and then recursively continues looking at the next element of the original disk. And then if it sees an empty block, it pops off the last, like, we kind of have a queue in a way of blocks that want to migrate left, and we just pop something, or not it can be a stack, whatever, which is just effectively a reversed list. Like, we have another list that's the original disk viewed in reverse, and when we say, oh, give me a block to put here, we pop this off of the reverse view of the list and then emit it as an element in the finished disk. The problem with that is that it's not really true that we just have a reversed view of the list and that's our stack of all the things to move. Because at some point, we get, like, up to an item that in the original list, in the original disk, there was a 7 written here. But by the time we've scanned all the way up to here, filling in empty spaces, we've actually removed this 7. So you can't really just have two immutable lists that you treat independently. Maybe it really is a good idea to just use a mutable array here. So Haskell famously is, you know, one of the more functional languages out there with the strongest focus on immutability. But you absolutely can reach for mutation if you want it. The type system just makes you admit it instead of sneaking it into functions that look like they're pure. Because it would be really easy to maintain two cursors into an array, and when we get to an empty block in the array, on the cursor moving right, we consult the cursor moving left and say, keep going till you get to an item, and then delete that and, you know, mark that as empty, and then tell me what item you deleted, and I'll put it here, right? And then you can just keep scanning until, well, I guess until the two cursors meet, right? Because when you get to this first empty space, or this empty space in the result list, it won't be necessarily obvious to you that, like, unless you notice that you've passed the other cursor, you might say, oh, I need to fill this in. Hey, other cursor moving left. Could you find me the first thing you see? And it'll be like, oh, sure, there's a 6 right here. Because it's moved all the way past this, right? And so you would then copy this 6 and put it here, and it would be fragmented again. But once the two cursors pass each other, we know that the left side of the right-going cursor is all full, and its right side is all empty, because that's the right side of the left-going cursor as well. So I think that makes sense. I think we want a mutable array. Okay, sure. Why not? This is a function that it should be pretty easy to write in the same way in an imperative language, because we really will be modifying the array out from under. We won't be able to... So a nice thing about functional languages is you can do recursive search very easily, because you know that even if you modify, like quote modify, if you produce, like, I don't know, when you try to rebalance a tree where the tree in an imperative language like has actual links to the left and right, you have to be really careful that you don't modify something and then like change your mind about it. And make sure you repair all the backlinks. Whereas when everything is immutable, you kind of just like can't help but get it right. And we won't have that advantage here because we are going to be mutating stuff. So let's see how that looks. Import data. So what the... I don't use arrays, and especially mutable arrays that often. So I forget what module they're in and like. So what I know what I want is an ST array. What is in... No, I don't want the one from GHC. I want the one in data array ST, I guess. I want ST array. Now, does this module really not re-export all of the editing features? Okay, fine. Import control monad st. I need st. Oh god, I don't know what I need. I'm sure I need run st. Probably exec st is fine, actually. Let's just assume that everything else we need is actually in data array st. I'm not sure. So st is the monad for contained mutation, where you can kind of declare a portion of your program and say, you know, within this portion, I can create and edit mutable references. And the type system guarantees that none of those references can escape outside of that portion of the program. So nothing can ever mutate, except for stuff that is explicitly inside of that area where you've opted into mutation. So I want st array. What else do I need? Oh, run st array. Yeah, maybe I don't actually need exec st here. Because run st array. Frankly, I could use stu array, unboxed array, because I really just need ints, and I don't need them to be lazy at all. Yeah, stu array seems fine. Or the old stu array. And then I'll need a bunch of operations from... it does re-export data array marray. Okay, so the... I don't know, you could look at but I'm just talking through, I don't know, I guess so data array marray. Yeah, it's an marray. We have index, which I don't necessarily need. I probably do, because I need to know the pointers. So what do we have in here? It's like have min max or range. No, what does it have? I mean, an index. I just have a pair of things, right? I don't know. I don't think I need any of this. So I have a new array. I have read array and write array, which I will need, I think, both of. I don't think I want folds over this. I don't need any maps. I do need get bounds. Probably. Yeah, sure. Just so once I've built the array representing the disk, I can be told what cells in it are valid. And I probably want get a soaks. That makes sense, so that I can yeah, so that when I'm done, I'll use that to compute the checksum, I think. Well, the thing is, though, I don't actually need get a soaks, because that's for working with M arrays. And won't I... I'll have a U array when I'm done. Although, actually, I think I probably want... I don't want ints in my array. I want, like, maybe ints or something like that, right? So I probably just want... run st array, not stu array. I won't use unboxed. And so what's in U array? The arrays are so complicated in this language. No, not U array, excuse me. Array. So we have lists and a queue. Yeah, so it's just a soaks. It's not get, because we're not doing it inside of, we're not doing it to a mutable array. Okay. So the other thing is, what exactly is the type of run st array? Oh, I guess this isn't that interesting, is it? I mean, I guess it's fine. If you have a stateful action producing an st array, it can run that stateful action for you and give you back an immutable array as a result. And I guess I do have that, right? I want a function that produces an array at the end as a result of some state operations. So this makes sense. But how do you make an ST array. Its type arguments are the state, the index, which for us will be int, presumably, and the element. But how do I make one? I guess it should be an M array somewhere, right? New array or something? Yeah. Ooh, do I actually have new gen array? That was one thing that I couldn't find. I don't want gen array today, I don't think, but that like last year was supposed to exist, but I didn't have the right version of base or something. I bet it exists now. So if I just said import data array M array, what is the type of new gen array? It exists! Okay. And I think there's something similar in iArray. I'm curious now. So, if I do search, yeah, gen array. So you can just tell it, I have an array, here are the bounds, and I have a function that will, given an index, produce the value that should go with that index. Please build the array for me, rather than having to build all the associations yourself in the right order. So if you have a list of items and you want to put them into the array, of course it's useful to use like list array. But if you don't have that and you have a way to compute what should go somewhere based on its position, it's nice to have gen array. And I couldn't figure out how to use that last year. So, okay, we have arrays. And I think new list array is what I will want. Because I'll just pass it, I'll map over the input disk or the input string and produce disk contents for it. Or, well, I'll probably fold map or concat map. I'll bind over it, but whatever, same thing. Actually, maybe it's like a fold M. Anyway, either way, I think this new list array is the. Oh, sorry, I forgot you were still looking at that window. New list array is the thing I'll want, I think. So. New list array. Oh, we end up needing a lot of stuff. But I think this is basically everything I want to deal with arrays. So let's define data. I mean, we could just use the type alias over maybe, but I think it's nice to have. So what do they call this? Your disk map, layout of files, files and free space. I mean, I guess this is a block, basically. Data block is either free or a file with an identifier on it, like a file block indicating what file it belongs to. That makes sense. I shouldn't really need anything but show on this, I would think. So one thing I think I want to write first is my input function. Where I take the string, I'm thinking, what exactly? I want some kind of fold, obviously. And it's like a slightly stateful fold that you could very easily just write as a recursive function. In fact, let's maybe do it both ways as an exercise. And I can write it the naive recursive way, just to get a little bit more comfortable with how it's going to look in the end, like what exactly I need to do. So we can say, I mean, this will really be our prepare function, I think. Prepare, I guess I can put it here. I guess our input is a list of blocks then, right? Seems true. Is go 0 composed with init to drop off the new line at the end, where go of ID file num and a dot. Well, it's a little tricky. Because, oh no, hang on, I forgot. That's not the input format. That was just how it was so the input is this, right? So it's 2 blocks of a file and then 3 blocks of empty. So of course we don't have this. Oh, and also, I forgot, each of these files is actually an int representing, yeah, so we actually have to I think we want to be like in, actually, you know what we should do, of course. Let's say file 0. We're going to have 2 mutually recursive functions. One that handles a file and then passes off to a new line, one that parses an empty block, and that parses back off to the file one. Yeah, I like that. File of so instead of init, then I can say, let's see, map digit to int filter is digit. So file n of empty is just empty. File n of size rest, I guess, is replicate size n cons to empty n? I think that makes sense. So we could have file kind of do both things, like slurp up a size and a next. But we don't know whether the last file in the last number in the input is going to represent empty space or a file. So I think it's nice to just have two co-recursive functions, or mutually recursive, I should say, that hand up control off back and forth with each other. And empty of n and empty is just empty. Empty of n and size rest is not n, but file n. Replicate size free cons to file of n plus 1, right? So if we then said empty is applied to the wrong number of arguments. Oh yeah, rest, there you go. Define but not used n, that certainly is true. And now it's warning me about defined but not used empty. That does bother me. What do you mean it's not used? It's right there. I'm using it. It says empty. I typed this wrong. Could match list of block with block. Indeed. I shouldn't be consing. I should be concating. Okay, and then there's a bunch of warnings about unused modules. But if I said prepare of read file input.txt, it's a large thing, huh? But it isn't, wow. It's not infinite, but it is 94K. 94,000 blocks. Okay. Does that seem plausible? Oh my goodness. It's 20,000 ints. Okay. And if each of them is about, on average, 5. Oh look, zeros are allowed. I forgot about that, I guess. I didn't know. Yeah, they did have one of those in the example, but okay. So on average, it should be 4.5 if this were randomly distributed, right? So 4.5 times 20,000. Should be less than this, isn't it? 4.5 times 20,000? 90,000. Okay. So it's a little bit larger than you would expect, I think. Because 0 plus 0, the numbers 0 to 9, yeah. Their average size is 4.5. Okay. Anyway, so this looks like it probably worked. But let's confirm, I guess, by saying take 20? Like, so we have vial 0 taking up 3 blocks. And then 1, 2, 3, 4, 5, 6, 7 free blocks. Yeah, looks good. Okay, so the parsing, no problem. Yeah, and with a thing that's 20,000 long, you do want, or 195,000 actually, you do want to handle it somewhat efficiently. It would be fine to use a linked list as long as we're not doing like quadratic size operations on it. But we're going to use an array, and that'll definitely be good enough. Is it possible I just want to commit this? Well, no. I mean, I did kind of want to write prepare using higher level operations. A fold over the list. But I think that was back when I misunderstood the input format, and with the actual input format, it doesn't seem so easy. Right? Like, I think I'm not going to do that. Okay. So let's commit this, I guess. Yeah. Day 9, types and parser. I mean, calling this a parser is generous. And there's not much in types either. It's basically just a bunch of imports on stuff I hope that I'll use, but I don't know. Maybe I won't. So, notably, our input is a list of block. I didn't make it an array yet. Normally, I like to have the input be the same object passed to part 1 and part 2. And with strArray, we can't really get an strArray at the top level. What you can get is like a stateful function that knows how to work with strArrays, or like stuff like that. And so I think in part 1, I will convert this list into an strArray and then operate on it. And I assume in part 2 I will probably also convert it into an strArray, and so I'll have 2 different strArrays. The cost of making an strArray is nothing to worry about, so I'm not too concerned about that. I'm going to take a short break before I get started, though. All right, I'm back. Obviously, since I cut the recording there, I don't feel like I have to tell you guys that I'm going on a break, but I also know that like I'm going to come back and forget what I was talking about, and it's just going to be weird if I suddenly seem like a clueless idiot. More than usual, I mean. So, I don't know. Okay. Input is an... Hang on. Right. I haven't made an array yet, which is why I don't have the indexes set yet, and that's all fine. And this is one problem where we're not really free to choose our own coordinate system. Obviously, like a one-dimensional coordinate system, there aren't that many degrees of freedom. But like there are. You could call this. You could start the array. You could say, oh, this one's 3. 0, 1, and 2 don't exist. Like you could do that if you wanted. Or you could say, you know, this is 10 and this is 0 over here or whatever. So there are some freedoms to choose your coordinate system. We could here, but the checksum method at the end does explicitly label the leftmost block as block 0. And so I think we should use that as our coordinate system. 0 and then increasing from there. So part 1 is going to output an int, and it's going to be a while before we actually have an int, but that's okay. Part 1 of blocks is... What is the type of read array, by the way? That works on M arrays and I arrays, right? Maybe. Data array... No, of course it can't, because it has a different type. But that's okay. We don't ever... We're not going to have to read the array when we're done, only while we're working on it. Because when it's done, we'll call... Oh, I don't even want to get a soaks, do I? Because we're calling a run st array, and it's going to give us back the finished array, non-mutable, of disk blocks. Right, which is why I put this one here, but I forgot to remove the one here, I guess. Okay. Let's say checksum of do, and then this do is going to be in st. Excuse me. No, checksum of run st of do. And I remember there's some, like, normally you write stuff like this, right? Compose checksum with run st, and then compose two functions, and then several functions. Foo.checksum run st applied to whatever. And I remember there's some issue where you can't. I don't know if it's exactly in this case, but there are some cases where you can't do that with run st because it's got kind of a weird type. And so it's I don't know exactly where it's specially blessed. I think it might be that it has special understanding of specifically, I don't know, whatever. Anyway, I'm not going to do it. So we're going to do checksum of run st do. So run st is going to give us back an array, and we're going to checksum it. And you know what? We can write checksum first. It's nice and easy. Where checksum, I guess that's one word, is we're adding these together, right? Yeah, multiply the block position by the ID number. Sum dot zip with score, starting with 0. Oh no, I don't even need to zip with because I have the soaks, right? Map score soaks. Score of what do they have? Blocks position, I guess. Is that what they call them? Blocks positions. Okay, pause. Well, the score of a free block is 0. Score of file num is pause times num. And undefined. Is this still all type check? No. Run st. Run st, right? I don't want run st. I want run st array. Okay, this all type checks. Great. Do. So now we're in st, and we need to produce an st array of the finished disk. Before we can get there, of course, we'll need an st array of the initial disk, and then we'll do some operations on it. So let's have our disk be new list array from, no, you do it like this, from 0 to length blocks minus 1. I guess I don't need these parents, do I? what are the arguments to new list array? In M array. Yeah, it takes bounds and a list. Perfect. That's all I wanted. I think it genuinely is just blocks, right? Because we've already done the thing of replicating them to... We've taken the widths and spread them out into the appropriate numbers of blocks. So each block will know whether it's free or what file it belongs to. Perfect. Okay. Actually, let bounds equal... Yeah, we're going to need this, aren't we? I don't need the bounds exactly. I need... Well, I kind of do. Let's let bounds as left and right equal this. So we are going to have 2 pointers, left and right. And we're going to initialize them to be 0 and the rightmost index. Okay. And I think at this point we just want to go left, right. I'm going to have to... These should have 1-letter names, right? That's how the cool kids talk about arrays. I don't like naming something L because it looks too much like 1. We could call them P and Q, very classic. S and T, I don't know. Go PQ if P is greater than or equal to Q is... That's when we're done. Actually, yeah, I guess this is fine. When we're done, we should just say pure, no, not pure, because our disk is already an ST. What is the type of run ST array? Run ST array. It wants an ST of S, the phantom type parameter that lets the type system guarantee nothing ever escapes. An ST of ST array. And I guess in this scope where I've already bound disk type is not ST of ST array, it's actually just an ST array. So I think I do need to say pure disk here. Yeah, that makes sense. Otherwise equals do, I guess. Well, maybe not. Maybe what I want is read array. What order does it take its parameters in? The array and then the index? I'm guessing. Let's see. Yes, the array and then the index. Read array disk P bind that to lambda case. So we'll read what's at the P, the leftmost position, and then pattern match on the result. We can't say, as we usually do, case read array disk P of, because read array disk P isn't an int, it's an st of int. So we need to bind that before pattern matching. So if it's free, we just say go of P plus 1 and Q. No, the opposite. If there's something there, then we shouldn't move another block on top of it. If it's free, then we should do something. We should actually, you know what? I feel like I should read what's at P and Q, so that it's easier to do the recursion when, yeah. Let's do that. So let's tuple up the results of running read array disk P and read array disk Q. So now we can say if P has something there, we don't care what's at Q, let's just increase P. And if Q is free, we don't care what's there. Well, we don't care what's at P, we want to decrease Q. And then we can say, if there's free space on the left and a file block F, then we can just swap them, right? I think that makes a lot of sense. I was thinking about, we're going to scan the left one at a time, but then when I find a space that needs to be written into, how exactly am I going to, move the right pointer left over and over until I find the next block that I can write to? But I don't have to, because I can just do them both at the same time and only do anything interesting once they're both showing exactly the kind of data I want. So now I just want to write array I should write array disk P of file F, and then write array disk Q of free. Let's maybe put that on a new line, and then go of P plus 1 and Q minus 1. That seems pretty good, right? I think this function might be done, but it can't be. I must have something wrong somewhere. I don't know. Let's see what the compiler thinks of it. I don't have lambda case? That's not in GHC 2021? It's It's in GHC 2024, I think. But I'm not, I don't have the right versions to get that. Last statement of a do block must be an expression. Please explain. Ah, indeed. I never called go. I defined it. Go of left, right. You know what? Left and right is stupid. Let's just not define. Oh, yeah, I guess I will. Curry go. No. Curry go of left and right. No. Uncurry go, or left and right don't even exist, brother, of bounds. So bounds is a tuple. When we uncurry go, it goes from expecting 2 arguments to expecting a tuple. This makes sense. Hey, it compiled! I never used get bounds on the ST array. That's true. What else? I didn't use ST at all. That's true too. This is why I shouldn't put imports in my first commit where I do unrelated stuff. Okay. Oh, and this function, well, I don't know. Should it be part of part 1? It's hard to say. The good news is it's just a function of blocks. So if I want to extract it, I totally can. Well, let's do it. Let's defragment takes an input. Oh, it takes a list of block, really, and returns a list of block. I think that makes perfect sense. Defragment blocks is this. And then part 1 is just checksum composed with defragment, right? Oh, whoops, this part should have gone up here. And of course we could inline checksum, it's short enough, but it's useful to have this name, I think. It makes it easier to understand. So let's see, this still compiles? No, I messed it up. Explain. The assocs should actually be here. Oh, which means a list of pairs of ints and blocks, I guess. That's a little bit less clean of a separation than I would have liked. Good, now I don't even need ST array. How nice. Boop. That's a number. Okay. And we haven't come close to max bound event, so we probably didn't accidentally get way too big. Could be right. Let's try it. That's the right answer. Great. Okay. So I really ought to like, I don't want that. I don't know. I feel kind of bad about having these imports that I wrote for part 1 that were like for the parser part, and then I didn't end up using them, and like really I ought to edit that parser commit, right? I think I can do all of that. Yeah, so if I just said this, really I should just stop writing imports before I know I need them, but it's so annoying to go back up and down the file, and I don't have proper IDE support for like adding them for me. So overall, how do we feel about this function, this solution? I think it's reasonably nice. It's more verbose than you would have in a language designed, tailored for imperative algorithms like this. And not in a way that I think is like good. I think it is more verbose mostly for like no good reason. The reason being just like, well, the language supports other models of thinking, and so you have to specify what model you want to use, and there's noise in that. But it is nice and explicit, at least, about where mutation is happening. And I think this algorithm is a good one. It's not as fast as it could be because, once we find a place that P wants to be, we're still like reading P over and over. And we're like, until we find where P should be, we're reading Q and throwing away the result. And then just checking the P and being like, oh yeah, well, better throw that away. Like, we could do this a little bit better. But this is fine. It's just like constant factor stuff. So let's see what's going on with part 2. Upon completion, 2 things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation was a bad idea? The eager amphipod already has a new plan. This is what I wanted to do to begin with. Sort of. Rather than move individual blocks, he'd like to try compacting the files on a disk by moving whole files instead. This time, attempt to move whole files to the leftmost span of free space blocks that could fit the file. Attempt to move each file exactly once in order of decreasing file ID number. Starting with the file with the highest file ID number. If you can't move it left, it just won't move. Well, the funny thing is, isn't the array that we built for this part a terrible data structure for this part? Because really, now what I want is basically a list, I think, of like a thing saying there's a file here of size 0, and then there's 3 blanks, and then a file labeled 0 of size 1, of size 2, then 3 blanks, then a file labeled 1 of size 3, then 3 blanks. And so the idea would be, I would say, okay, 99, that has size 2. Find me the first place that there are 2 or more blank spaces in a row. decrease the size of that empty slot, and then replace this empty slot. Or, well, really, I guess, concatenate it with what's around it. Yeah. I think this data structure is just bad for what we have. The annoying thing is, like, checksum already works. Well, actually, no, checksum works on lists of blocks, doesn't it? It does. Or works on list of pairs of instant blocks. Okay. Our input is a list of block, however, which isn't exactly what I want for part 2. What I want for part 2, I think, is closer to the original input, where we just... I mean, you could do this with our existing algorithm, but it kind of sucks a lot with our existing data structure. Like, you could start at the right side. Find... Yeah, I don't know. Because you have to find, like, oh, okay, I found a 9. Let's scan until I found something other than a 9. Now I know how big the 9 is and where it starts. Now look here for a thing that's the right size. I just think the original input format we were given is better for doing part 2 than this block thing that I built for part 1. Yeah, I guess so. So I'm going to have to change my prepare function to do... So we still need to do this bit about iterating back and forth between, or alternating back and forth between files and empties, files and frees, I guess we should call them. But then I don't want to do the part where I, like, replicate, basically. I want, like... Okay, so maybe what I want to do is have this prepare function be parameterized. Where it takes it takes a function here from block and list of A to list of A, and then it returns to you a list of A. Does that make sense? Oh, block, not a block. Actually, is it a block? No, because I want an int and a block. Yeah, this sort of makes sense. So we're going to say, I'm giving you 5 frees, or I'm giving you 6 blocks of file number 7. What do you want me to make of that? And then the list of A will be, of course, what it gets from calling itself recursively. Can I just write F here? I think that's fine. Is F size and file A, and then call empty F size and free on this. So this won't type check, but if I strip the prepare off of there, say sadly, am I even using the type input anymore? Not really. So part 1 takes a string, part 2 takes a string, and it starts by calling prepare lambda len b b's to replicate len b b's, I think. So does this type check? Yes. And it gives me the same result I had before. Okay. But now our prepare function is more general, and we can use it to produce a different input type for part 2. So part 2, let's just for the moment have it return a list. Well, let's not even give it a type. You can just infer that for me, please. Is prepare len BBs give me data chunk is a chunk int block describing how wide the chunk is and whether it's free or whether it's another file. So I want a chunk len b const b's. So this does compile. I don't want to run it on the whole. I guess I could. I could say main, and we're going to get a huge thing. But notice that, like, the file numbers are decreasing, and they're alternating with free chunks, and there's 10,000 of them. Yeah, that makes sense. So we have 5 free and 6 at the end. Does that all look right? Yeah. Okay, so that has parsed fine into the format I hoped it would have. Now, we'll see whether I can make much use of that format. It's actually a little bit... it's a little bit hard to do this without n-squared operations, isn't it? And like 10,000 squared isn't huge, but it's not nothing. It would be nice to avoid doing 100 million things. Yeah. Yeah, maybe a list isn't so hot, but that's fine. I can, well, I mean, I can't really, can I? I can't just build an array using this. That would be the, like... Oh, you know what? Maybe what I need is a sequence. Log time, split, and concat operations are what excite me today. Yeah. Okay, so... but I don't want cons. Yeah, see this is fine. I can just call s.fromList on the result. So we'll have then a sequence of things. And this is also fine. We'll have a sequence of chunks, which is still quite useless. Oh, right, main, right, okay. Yeah, produce a seq of chunks, great. So let's go look at sequences for a minute. So a sequence blah, blah, blah. They have similar names to lists. It's for a wider variety of efficient operations. Constant time access to the front and the back. And logarithmic time concating and splitting. Which, you know, necessarily also gives logarithmic time access to any item. And I think the constant factors for sequences are not all that great, but it's well worth using for, like, you know, a list of 10,000 items that we're going to be manipulating in the middle regularly. So... are we ever gonna... is there gonna be some reason we would move a file to the right? What is the algorithm we're supposed to do here? Move whole files to the leftmost span of free space blocks that could fit the file. If there's no span of free space to the left of a file that is large enough to fit the file, it does not move. Okay. So... So we never need to move a file to the right of where it is. The other thing is, really, I need more than just this sequence, don't I? I want to know for each file what index and size it started at, because that's definitely where I will find it in the list. So I don't have to scan inwards from the right, ever, looking for the right file, because it'll just be where I want it to be. And then I can scan rightwards from the left side of the list to the first place where I can fit that file, or the file itself, whichever comes first. And then I can do some surgery there. Now, I bet you could do something more efficient. I mean, that should be efficient enough, what I just described. And I don't exactly want to make my own heap allocator just for fun today. But what if I thought about doing things sort of like that? Like, really, I don't care as I'm reading the blocks. Like, as I'm moving stuff left, I don't care anymore about where any of the actual files are when I'm deciding to move stuff. I just need to know where the blank spaces are, right? So maybe what I do, well, yeah, if I if I start with, like, a list of I mean, really, it shouldn't even be a list, right? We could do better. We could have a heap or something? Does that make any sense? It's kind of hard. Well, what if we had like a heap for each potential file size ranging from 1 to n? What if we had a heap of all of the positions at which a blank of that size appears? I don't know, it's kind of hard. Because ideally, like, there'll be some, I don't know, I mean, we could say, all right, I'm going to start working on file 99. Here's its size, file 9999. Here's its length and position. Scan the disk from the left for the first gap it'll fit into. Put it in that gap and fix up our disk. But file 9999, or in this case just 9, will never change after that. I never have to look at its... I can just immediately say, that's the result for file 999. It goes here, right? And then I would just have to fix up the list of free space. So if we were doing scanning from the left, okay, I would replace one block of free space with either one new block or perhaps 0 blocks. Like if we filled these two, as in the example for 9, I would replace a block of size 3 with a block of size 1. Whereas in this case, when we put file number 2 in, I would replace a block of size 1 with no block at all, no free chunk. And that's fine. You can do that. The list of free chunks will be at most size 5,000 and getting smaller. And you'll access it 5,000 times. That's like 25 million-ish. Well, half, call it 12.5 million sequence lookups. But I just feel like there's some... I know that that would be efficient enough for Advent of Code, but I just... What would be a way to do this efficiently is what I'm thinking about. I've not made a lot of progress on that as I try to explain it to you, but we could certainly have an array of input or a list of input files and a list of output files. That's no problem. The question is, how do you index I mean, okay, let's say that I already had an index by like a map from file size to list of places or set of places or heap of places or something like that, where a gap of exactly that size begins. So to work with file number 9, I would say, hey, is there any place where, like, you would basically query each of them from size 9 down to 2, or 2 up to 9, it doesn't really matter, and find the leftmost of those, the earliest one. That would be the gap you would want to write into. You would either erase that gap from the list, the map, the set or the heap or whatever that you took it from, and you would either not replace it at all, or you'd put a smaller gap into the heap of the correct corresponding size of whatever's left over. So in this case, we would find the gap of size 3 is the furthest left. That is at least 2. Replace it with a gap of size 1. So in that way, we would only have to do 10 1 through 9. Yeah, we would only have to do 9 heap lookups for each file and a couple of heap edits. We wouldn't even have to maintain the actual disk itself at all. Just a list of the blocks and their positions. And a bunch of heaps of the describing the shape of the free space. So that's a way we could do it with 10 or 9 heap lookups each file. Can we do better? What if we had, like, for each file size, a heap saying, here's where you can find the first gap of at least this size. Then we could certainly look up, I have a file of size 2. Where's the first gap of size at least 2? And then you could go there. The problem is you would have to then change every number small. You'd have to change all the heaps representing gaps smaller than that, potentially. Because you're turning a gap of size, it turns out, even the ones larger, you have to change like every heap every time, I think. In a way that I don't know how you would even do. So it would make lookup faster, but it would make maintaining the data structure much harder. So let me look real quick here at, like, what is a heap? Module data heap? Is that the one I want? Is this a popular one? That's by Edward Komet. It's probably good. These are asymptotically optimal Okazaki heaps. Okay, that's probably what I want. Implementation of priority queues. Yeah. So what operation can you? So the issue would be if I. Well, yeah, I guess I'm only ever getting the leftmost item out of the heap. And I never need to delete an item from some other heap, only the one I got the item out of, right? Because if we imagine we're keeping 9 heaps, I'm going to query n of them, where n is, 9 minus or 10 minus the size of the file. But one of them will have the best answer. Okay, so what can you store in a priority queue? I don't use heaps very often. A min heap. Yeah, I think that's what I want. So heaps are foldable, okay. So an entry is a priority and a payload. I kind of... I don't think I even have a payload, right? My payload could just be unit, right? And I think that is okay. I'm just going to put in ints. And I want to get out the smallest one from each thing. that makes sense. Yeah, okay. Now maintaining 9 maintaining 9 heaps in a loop, you're obviously not going to want 9 parameters to your recursive function. So you can either have one parameter that's like a map from int to heap, or like have a stateful function where you put all those maps in the state. But either way, well, we could have an ST array, I suppose, of ints to heaps. But I don't need to modify the array. I need to modify the heaps. So it could be an array from int to an stref of a heap. Does that make any sense? Why not just have an st array of int to heap if you're going to do it that way? Yeah, I guess an st array mapping ints to heaps makes sense. And what about maintaining the output list? I could like use writer and tell every time I determine where a file belongs. But I think it's fine for my function, my stateful function. Wait a minute. To return... Well, it's kind of hard. If I just use run st array, I don't have a return value to smuggle the final file positions out in, I don't think. So let's review st array again. So run st array just gives you if you have a function or if you can statefully make an array, it gives you just that array, no space for any extra values. But st array is an instance of M array. Although it depends on st of s. Am I not allowed to... Well, let's see. I think st array or M array lets you do more stuff. Not really. Well, what are the instances of M array? A bunch of stuff in IO, a bunch of stuff in ST. It doesn't support like monad transformers. You can't have like writer T of ST. That's not allowed. Okay. Interesting. So I could run a program in ST where I have an stref of the results that I want to produce, the files and their final positions, and also an st array of heaps. And then when I run that st operation, the final result can be like dereference the stref and freeze the array. Well, I don't even need to freeze the array. I don't need the array when I'm done with that. I'll have the only thing I care about is the list of file positions at the end, which, oops. I guess I don't even need an stref for that, because I'm pretty sure I can just get that all out in the return value. Okay, I mean, this seems like a fun challenge. Like I said, we don't have to be this efficient, but it's an interesting idea, and I like it a lot better than just doing this dumb thing with sequences where we access 25 million. We build like 25 million. Or I guess it's not even that many. Well, yeah, this would be scanning back and forth through a large sequence, large-ish. A largish number of times. So where is heap? It is in the package heaps. Okay, so I've changed my mind. I don't want sequence at all. Which, fortunately, the only thing I did was put s from list in there. Okay. What I do want is heaps. Yeah, that makes sense. Oops, no. I meant to do this. It's building heaps now, I assume. Yeah, okay, that's fine. So I'd like to play around with them a little bit. Import data heap. How much of that, like what's even in there? Function names clash with prelude. You should import a qualified as h or heap or whatever. Fine. But for playing around in the REPL, or in, I guess they call it GHCI. REPL's a Lispy term. But everyone knows what you mean. Empty, yeah, so you can insert stuff that I assume there's a from list or something. To and from lists. From list takes a list of things and builds a heap of the thing. Well, so what's the deal with payloads then? What's entries? If you build from list of an entry? I see, but if you don't need separate payloads, you don't have to use entry, I guess. got it. Yeah, so if I just say from list of 392, it says, here they are. They're in sorted order for you. 2, 3, and 9. Perfect. And what are the, like... basic functions? So we have empty, null, size, singleton, insert, delete min. Adjust min? Is that what I want? I think I want view min, basically. Which is the same as uncons. Okay. Where for each... oh boy. This seems hard. How do I... I'm going to have an array of, well, an ST array. And of heaps. And I'll query some subset of them. And among the ones that produce a just result, I wish to find the one with the smallest first element, this, and do some stuff to it. Replace its entry in the array with its second part of the result, the heap without this item. Yeah, I mean, it's all possible. It's just kind of hard. So, roll up your sleeves, I guess. So let's import heap as H. And now, joke's on me, I do want this stuff back in ST, right? I need... oh, run something, some monad gets you the state, or the effects and the value. Exec gives you just the value, or just the state. They call it eval if you just want the value and not the effects. So I think I'll need eval st. I'm going to need data map. Really, I guess I could use int map, I suppose. More efficient. No, I don't need a map. I'm using an array, you dummy. Okay. So I want to say, part 2 of input is, geez, it's eval st of do. Oh, it's probably a lot. I don't know. I'm not really ready to call eval st yet. Am I? I don't know. This is too complicated. So I guess something that would be useful to do is first, I don't know. Let's say eval st of do. I want a where block here where something equals prepare this on the input. So I'm going to need to refer to this probably multiple times, I would think. I guess I could just put it inside of eval st as well. Sure. Maybe I don't need a where at all. Let chunks equal this. Fine. I need the list in reverse order of all of the files and their positions. Right? Of all the chunks. I have all the chunks. I need just the files out of it and reverse order. So let's do that. Input files equals reverse. I'm sure that there's some more efficient way to do this where you use like a difference list to build the list in the right order to begin with, but forgive me. Reverse the problem is that none of this stuff knows its position. I just have lengths. I built a chunk of length, n, and I said it's a file, and then a chunk of size m, and I said it's free, and they're one after another. But I don't have them. Don't have them labeled. And that's some kind of fold over the chunks, right? Blocks? I don't know. Is fold... What the hell is the type of fold RM or something? Or maybe do I just want fold M? What is that type? Foldable T. Do I probably just want? Do I want traverse? Traverse is basically just map M. Sorry, daydreaming here. Yeah, so the thing is, like, I want my... Yeah, I think I want traverse. So A to FB, where A is my chunk, and F is like state. Or hell, I mean, even it could be ST. Why not? Since we already have that. And it's just a more efficient version of state. Well, it's not, because you need an STREF? What actually can you do in ST? Do you need STREFs to do anything interesting? I assume so. Safe is... what? Why did you link me here if this is the deprecated one? Safe is the default. Use control monad st lazy. Okay, fine. I'm editing the URL directly because I can't figure out how to use it. I couldn't find a link to where you wanted me to go. And I don't even need lazy, right? I want it to be strict, really. So this is the module I want, control monad st. That's the one I'm importing anyway. State thread. So an st of a, yeah. Okay, but where is stref? I guess I have to search for it. Oh, I want write stref. It's in stref. Okay, so this is like the only thing that st really gives you at a low level, is the ability to create, read, and write these things called strefs, which are mutable references within the context of a state. Okay. So that's what I want to... I'm kind of annoyed. I shouldn't mapaqml basically do what I want? Where am I? Mapaqml. Traversable T, yes. Which I think is just going to be like a list for me. An S, my state, which will be the int, the position at which each chunk starts. An A, which will be the next chunk, producing an S, a new index, and a B, which will be an indexed chunk. Yeah, all I need for this is mapqml. I don't have to roll my own, or I don't have to do everything by hand with an stref. I'm fairly sure. Okay, so this is in data list. Okay. So it'll be verse of second of mapaqml index applied to chunks, I think. Let me go import data list map QML. Right. I want to label both kinds of, or index both kinds of chunks here. And then in the next pass, I'll split them apart. So I think I don't actually want the reverse yet. Index blocks of index chunk len b, I guess, is index I don't need b, index chunk, but I also need to return the new state, which is index plus len. This should be equals because it's not a lambda. So here we're defining a function in the middle of our of like some other variables. That's perfectly fine. You can always do that. It's just like it doesn't necessarily, it's not so obvious that this is a function, but it is. So I think this makes sense. This is gonna be so hard to debug when the types don't match up, man. I need to make some of this into higher level functions. Let's do this. Index blocks is a function from list of this is not, well, it's a function from list of chunk to list of pair of int and chunk. And it is equal to this, where, but instead of calling it index blocks, it's going to call it go. Go of this equals, okay. Index blocks chunks. And then just return nothing. So how does this check it all? Type check it all? No. Data array st. Okay, these are actually in st itself. Eval st doesn't exist? Oh, I guess it would just be run st, wouldn't it? That makes sense. There's no effects to give you, so all they need is run st. Hello? There we go. Yeah, it type checked. That's better than I expected. So we have labeled all the blocks now. Let's let input files equal reverse of f for sure, f for f, which is an index, which I'm ignoring for the moment, and a chunk len, which I'm ignoring at the moment, and a file whose ID I'm ignoring at the moment from blocks. So the idea is we're iterating over blocks, matching or extracting, let's say, the entries which match this pattern, i.e. they are a chunk containing a file, and some other stuff which we're ignoring and just returning the entire object as is. So does that type check? It does. Okay, good. So let's have what are we going to call this? Our heaps? Free heaps will be, how have we decided to make an array? New list array. New, actually, there's some way to say new array, but all the elements are the same or something. New array, every element initialized to the supplied value. I've never wanted this function, but I do this time because I'm planning to mutate it. How nice. Great. Okay, perfect. So actually I want new array here as well. New array which wants bounds 1 to 9. And then it wants the element, which is h empty. Great. Then we want to traverse over. Oh, actually, let's do. They gave us. That's why God gave us 4, right? For the f as maybe I just want to sequence A here because I'm kind of pattern matching already, right? Let's try this. Sequence A of do. Let's let index chunk len free. I don't need parents there. From blocks. So again, this will just, anything that doesn't pattern match here, it'll just skip, which is great. That's what I want. How do I modify the entry at an array? Modify array. Okay, so I need that as well. And we'll use the strict version because I don't need to be lazy here. And it would probably be bad to be lazy. modify array of free heaps at index with h dot insert of, no, not at index, at len. Right, we're tracking all the places where there are gaps of exactly this size. So we want to take the heap for this size and insert the chunk. It's at index. That's where it is. That's where there's a gap. Does this still type check? I need to import sequence A. I could, I guess, just use sequence, but I don't. I fundamentally disagree with that. Import control.applicative sequence A? Does that not exist? Do I have to use just... It does, but it's in data foldable. Weird. Okay. It's not crazy because like that's where traversable is defined. No, the traversable's in data traversable. I don't know. It's very strange. I don't understand where stuff goes. Couldn't match type list of unit with st of something. I can well believe I got this wrong. So sequence A, the idea is it lets you flip the nesting order in a monad in a way, or an applicative really, and traversable, but like, okay. You have, my intent is that this do block should evaluate to a list of st actions. And then sequence A will apply each of those st actions, throwing away the results, but not, of course, throwing away the effects. So what do you mean? Why do you expect an STS, but you get a unit? What is, oh, it's not, Modify array, well, yeah, this returns an M unit. That makes sense. So modify array tick takes an M array, which we have, and the M is st. Takes an array and an index, which is what I'm giving it, and then a function to map the value to a new value, which is what I have as insert ix. And then it gives back an M of unit, which is an st of unit. So how can it possibly be getting a unit instead of an st of unit? Because modify array tick isn't returning a unit, it's returning an st. Right? Modify array from date. Okay, so if I Yeah, that's the type I was looking at. I don't have some weird version that's different from the Haddix. Right, it's not... Or it is. Yeah, it takes a foldable... Oh. Wait, what? Oh yeah, F is the applicative. So we have a list of ST actions returning unit. And this should just give us back... Oh, wait a minute. I see. Maybe. So what's the error you have? You have a list? No, I don't see it all. Maybe I do. So the problem is this is a list comprehension in... This is a monad comprehension, a do notation, in the list monad. So I should be returning a list here. Shouldn't I? That's just worse. Well, maybe not. An M array A heap int. It can't tell what type I want to index? No, that's the only mistake? Okay, well, do I have to just say it should be an int? Nope. Really? An M array. Okay, so what the hell is the type of M array? A is the array type constructor. It doesn't know what kind of array, what kind of mutable array I want. Do I want an ST array or something else? Okay. Why can't it tell I want one in ST? Shouldn't new array... New array. Okay, so I guess the issue is, since I'm never using this array, it can't tell what type it should have. But I am, aren't I? Because when I say modify array, it can infer that the type of... Well, no, wait. It can infer the type M. What's A supposed to be? Okay, so I can have... A is the array itself. I don't know why it can't tell this should be an ST array. Fine. this is horrible. Let's put it here, maybe. ST array. Oh, God, and what types? ST array, SI. But I don't know what S is. That's the whole point of ST, is you never get to find out. S int H heap of int. It's not going to like this. I didn't import ST array. Okay, fine. It still can't tell. Yeah, this time it's for exactly the reason I said. It doesn't know what S is. This is the type I'm not allowed to refer to because that's the type that ST uses to make sure you can't leak references to internal state. But why? So I could do this, saying it's for all S. Is that permitted? May I say that? I may say that. Okay. I don't know why I have to. We're in ST, and I said new array. I guess there could be... Oh, it could be... I could want an STU array, I guess, is the issue. Maybe? I don't know. Okay, fine. So this pure was necessary, right? It wasn't like a thing I added because I was confused about the last error. Yes, okay. So we have succeeded in a few things. What if I now said, please return for me the input files. Index 0 out of range. Oh, yeah, that's true. There are chunks of size 0 in the input, which I had forgotten about, where like two files bump up against each other exactly, and I don't handle that here because I'm assuming that the len is non-zero. So let's guard that len greater than 0, greater than or equal to 1. Import control monad guard. Okay. So how much sense does this input make? Obviously, we won't know for sure that it's correct. But it is, as we had hoped, in descending order. And it says in index 0, there's the chunk 3. There's a 3-chunk file named 0. And index 10, there's a 4-chunk file labeled 1. So we can confirm that that's correct by looking at the input, right? how should the file start if it looks like this? There should be 3, and then that's taking up spaces 0, 1, and 2. So 3 through 9 must be taken up by empty space, which means 7. So the input should start 3, 7, 4, I think. It does. Okay, so that part looks fine. So where is freeze array exactly? Freeze is in data array base, which hopefully marray re-exports. God, they don't even... all right, it's going to be a nightmare, but let's say I were to say freeze. Put it there, I guess. Freeze of free heaps. But I need it to know what type. It's going to complain again about what type I want. It doesn't know. Ambiguous type variable. Yeah, okay. As an STS of array, I think is all I need. Array int h heap int. Oh my god. Oops. Why are you upset about freezing? No instance for marray strarray s heap int st. What is wrong with you? What does this even mean? strarray s is not an marray? Why not though? Oh, S and S1. I think it's trying to trick me here. The type I gave it is just not good enough. Like, what the fuck? I hate working with ST. It shouldn't be hard, and it always is. The problem is, these two S's are different, I think, is the problem. They're both for NES. Wait, why am I saying pure? No, I'm not. I'm saying down here. Okay, so what freeze takes an AIE, your input array, and returns a B. Okay, so maybe I can get around mentioning S if I do it like this. Heaps is freeze free heaps, pure heaps, as an array int heap int. Yes, I'm allowed to say that. And so it produces a list of 1, well, not a list really, it should be a map, right? Or an array. Yeah, so, I mean, I can't tell for sure that this is correct, but it claims, well, we can check this, right? Because we know the input starts with 374. So this is the list, the next list we find, or heap we find, what is the order of these things? Let's actually search for from list. So 9 starts at 206. 8 starts, the first one of those is at 39. And there's a 7 at index 3. I thought the heap would be printed in order? But no, I guess heaps are like partially ordered internally and rebalance themselves when necessary. But it's not really necessary while you're printing to get them exactly in order, right? Just that the first one should be smallest. Okay, so this looks like, to me, the data structure that I wanted to create for the initial state. I haven't done any of the hard work, which is actually maintaining and using this data structure. But baby steps. Because this ST is just trying to kill me every fucking time. Okay. This is all fine. This stuff was all just for debugging to make sure everything was okay. Now what do we need to do next? We want to iterate a function over each file, I think. Which is going to mean calling traverse. Because I want to map over the list of files, producing a value and some side effects for each of them. And that is what traverse will do for me. Traverse, move left, input files, let move left of oh, you know, actually, do I want all of this data? I guess I do. I need the chunk and I need the file. It's a little awkward that I haven't proven that there's no... Okay, you know what? Let's do better here. Let's say index len num. And let's actually destructure this. There's no possibility of the file constructor is gone, which means we no longer have to worry about the free constructor potentially being in there. Move left of index len num is probably do. I mean, so the exciting thing is we have to, let's see, we won't be letting, we'll be traversing again, I guess. First, I guess, is traverse. What was the function called? h.minView? Oh, yeah, but I need more than that. Traverse. InView. Read array. Free heaps of 1 to 9. Oh, man. It's actually just like reading the entire array, isn't it? That's actually better in some ways. Ah, no, because I don't want to read all of them. I only want to read the ones from len up to 9. Because if there's a size 5 file, I don't want to look in the list of chunks of free space size 1, right? Does this still type check? Hello? It's not called minView. Oh, what is it called? We were just in data heap a little bit ago. Uncons view min. Okay, whatever. Move left. Ah, right. View min is not a monadic operation. It shouldn't be in the traverse. It should be outside. Close. Traverse read array from that list should produce a map. Good. Right. So the issue is this produces a list of the results of viewmin. And so I should be fmapping not just viewmin, but map viewmin over that list. Okay, we're getting somewhere. So how do you... I want like maximum by, but in a way that it would be in data monoid probably. I want like maximum by, but not failing if the list is empty, right? Maybe I just want to sort it and then match on whether the result is empty or not. I'm sure there's something better, like there's some monoid instance that would do exactly what I want. Right, like for maybes. Maybe wrappers, the Yeah, there should be like a min, right? And that would be just a semi-group. Probably. They choose the smaller instance as by the ORed instance. The problem is, like, I don't know, it's kind of hard. To get this thing built exactly the way I want it so that min would just work. So I don't think I want that. I think sort by is fine. I want sort by, sort on. I forget which is which. Sort on takes a function for yeah, I want sort on. Okay. From data list. Okay. Case sort on. Actually, I want to like map maybe this actually, right? Because if viewMin returns empty, I just like don't want to consider that one. Oh, the problem is I've lost track of which chunk size I actually found. So I'm going to have to do even more here. I have to, let's see. Oh, this is horrible. I have to get an index out of this computation as well. I have to get the int itself. You know, that's probably an okay function. If we first yeah, I mean first chunk, first free block of size is something. Let's say do, so I can just like write imperatively and it'll all be easy. H will come from read array free heaps of size. Case H viewmin H of, oh, so really I guess what I could do is bind it to lambda case. And if we have nothing, now this can just be an fmap, I'm sure, but I'm writing it this way first because I don't understand what I'm doing. Don't tell anyone. You have a maybe A. So A should be the first, the index. And remaining is the rest of the heap. So in that case, I want to return just size. No. Index size remaining. And this is very clearly like just an F map, right? If it's nothing, we do nothing. If it's a just, we slightly change the result there. And if I were willing to put size first, it would be a very easy, like, it would be an easy F map. I could just F map like size comma onto the result of read array. But I want index first so that it's easy to sort. Well, you know, maybe I can just do this. Fmap size comma onto this. And so that will give me a tuple where the outer part is size and the inner part has an index in second. So I want to like sort this by first composed with second, except the other way around, second composed with first. Okay. So now we can just traverse first free block here. Sort on look at the second element and then the first is like this. Oh, except it's not just traverse because I want, I guess it's cat maybes mapped over that. A list of maybe to, yeah, that makes sense. I'll probably have to import this. Oh, not until the compiler tells me, I guess. If it's empty, no, I have to also do a little bit more than this, don't I? I have to also filter that it's less than, that the index in is less than the original position of the file. We don't move files to the right. Less than, I suppose we could say less than or equal to, but it doesn't make sense. It would never happen. Less than the original index, the first, second again. Oh, this is horrible. But I think this is fine. In this case, we just return index len num, basically. Index len num. Or I already have I have the word chunk for that, don't I? Oh, but chunks aren't indexed. Yeah, okay. We'll return index chunk len. Well, no, I guess this is fine. Here. We don't have to do any side effects here. But if there was a free index, oh no, hang on, that's not the order things are in. Free size, oh gosh, free size, and then we have an free index, free. Hang on, what are we keeping in? What's first free block? Ah, it's not num, it's the remaining heap. Oops. Here. So if there's at least one element, then we break apart the first element into a size, an index, and a heap of the remaining things of that size. Then we do we need to amend the free. Okay, so let's write array free heaps at free size. Oh, write array. Is there even a strict version of this? I didn't import it. No, okay. Because it just always ignores the result. Okay, write array free heaps free size of h prime. So we've now shrunk. We've removed from the list of free blocks of this size the block we just filled part of. And when free size is greater than len, when free size is greater than len, I'm going to have to get that as well, then also modify array free heaps at free size minus len with insert of so we're adding to the heap for the smaller chunk size. Free index plus len or something? Seems right. The len of the file, yes, not the free size. And then simply return pure of, I think, the same thing here. Index len num, probably. How do we think about? Does this look any good? I almost feel like it's done. I'm sure I've forgotten something, and there's going to be a million compile errors, but this is overall what I think I wanted to write. Find the first place that you can put this thing. Actually, you know what? Oh, no. We should be returning index len num here. We should be returning the new place it goes. Free index len num. Yes. Because we're writing into the slot starting there. Okay, I mean, I don't know. What does the compiler think of this? Cat maybes. I told you I'd have to import it. Couldn't match type int heap int with maybe int heap int. Oh, yeah, well, cat maybes doesn't look right anymore, does it? Well, maybe it does. I don't know. So traverse first free block. Of a size, reads from the heap, and adds a comment. That doesn't do enough. Does it? No, I don't. My call to min view fell out somewhere, or view min. So we read array. Do I just want to do that? Probably not. Well, maybe. All right, I need to put some types on some of this stuff so that at least GHC will tell me what I've done wrong and what it's just guessing about, because I didn't tell it what I wanted. First free block is function from int to st of sts. Oh, fuck. It's for the same. It won't match because it has to be for the specific s. I hate st. So maybe I have to like put an explicit for all up here where I capture the s that I want to talk about in the rest of this file. So there's nowhere I can actually put it. Okay, well, what if I just let GHC wildcard that? Maybe it'll work. ST of something. And then it should return maybe an int and a heap event. That's what I wanted first free block to return. What say you? Oh, it hates everything, man. Found type wildcard standing for W, where W is like whatever. Okay, fine. But could you just like fill it in for me, please? Fmap. Okay, well, I mean, we're getting closer now. I'm just going to leave the wildcard type in there until I fixed all the other type errors, and then I can delete it, and it'll infer the right thing. I don't know how to get it to... There's some way to get it to, like, use the partial type. Oh, it's, like, called partial type signatures, isn't it? Haskell partial type signatures. Since 7.01? That's a while. I have no idea what version I even have. Let's just try that. Okay, great. It's willing to accept that now. Oh, mviewmin. I think I wanted some parentheses in here. Let's do it this way, actually. Int, maybe int. Oh, I guess I want to fmap that as well. To get it inside the maybe. No. Oh, well, actually, the type I wrote is wrong. I wanted this. Maybe the index and then, or maybe the size and then the rest of it. Oh, no errors. Okay. So first of all, let's put I can get rid of this stupid S now if I annotate this side but use a wildcard type. Right? No. Fuck you. Ugh. Okay, fine. I don't understand it. I mean, I guess I'm not done because all I've done is move the input files. I haven't actually scored them at all. So I'm mapping over each file and moving them left where possible. Let's just return... Well, yeah, let's return that and just have a look at it, I guess. Okay. I mean, that's way better than I thought it would be. It's a bunch of numbers and not a runtime error. And our input... What is the order of these numbers? What does it mean? It's the index at which we're writing the file, then the length of the file, then the file's identifier. So file 0 has been written to index 0 and has length 3. That's good news. That's where it started. We remember that one. And then we found space for a bunch of other files with length. Length is the third parameter, right? Nope. Second one. That's maybe a problem? This doesn't look right. Does it? Index, length, num. Well, I guess I don't have any guarantee that these... Oh, right. These aren't necessarily in order. It tells me where file 1 went, file 0 went, where file 1 went. File 1 stayed at position 10, which makes sense. There was no room to move it left. File 2, I don't know. I mean... Honestly, it looks like none of these got moved backwards. That's probably bad. Yeah, that doesn't seem great. Actually, even file 1 should have moved back, right? Because if we go look at our input, yeah, there were 7 blanks. Oh, right, but we're starting on the right. Ah, no, so I don't know if any of this is wrong. We started on the right, and there was a file of size 6, or maybe 5. I don't know if this ended with a file or a blank space. But anyway, that should have gone into this 7 here, 5 or 6 things. Okay. So it would be nice to kind of get some test of this on a smaller input before I start writing up the scoring. So I'm going to grab the test input. Nope. Don't paste that. Paste this. So that's my test input. And if I say test input text and run this, do we get what we expected? It's hard to say, huh? These are like sorted in a bad order. I should sort them on the index, I guess, to make this clearer, right? Sort on that makes sense. Nope. Oh, this is in... There we go. So it says, at index 0, we have file 0 taking up 2 blocks, which is correct. At index 2, we have file 9 taking up 2 blocks, which is correct. You'll have to take my word for it. I'm looking at this in another window. Then we have... Uh-oh. This isn't what we were supposed to have. At index 4, which does come right after file 9 has finished, taking up 1 block, we have file 2. You know, we could actually very easily just write a function that takes this list and outputs the list the string of ints that the input statement is phrased in terms of, right? fmat or what? Debug takes a list of int and returns a list of int. Debug of, oh no, it takes a single triple of int. Debug of index len file is replicate index file. Kind of annoying that it, okay, so this is actually all wrong. File 0 isn't in there at all. Wait, did I? Yeah, it wasn't. Replicate index, okay. Index len file? Huh. But I thought... Oh, not replicate index, replicate len, you big dummy. Index... So we write 0, 0, then 9, 9. That's correct. But there should be an 8 here. And, okay, good news, because 8 is the very first file, or second file that should have moved, the first one after these 9s. Oh, I'm looking at part 1. Okay, great. This is the results for part 2. 0, 0, 9, 9, 2, 1, 1, 1, 7, then a gap, which we don't... After the 7, there should be a gap of size 1 here, which we're not rendering in the debug view, but that's okay. 2 4s, 3 3s, 4 5s, 4 6s, and 4 8s. This is all in the right order. That's incredible. I'm so happy. I thought I might be here another 5 hours, man. Okay. So now we can actually just score this, basically, right? We don't need the sorting anymore. We don't need the debug. We can just say score this. I'll leave this in, you never know. Score of index len file is we can be a little cute here if we want to, or we could just like... So this is basically, it is, I don't know how to write LaTeX or LaTeX or whatever you say, like math, fancy math expressions. This is the sum from I going from index to len of file plus I, right? Which there's a well-known equation for summing a sequence of integers, which I could reproduce by hand. But actually, it's really easy to just ask Haskell to do it, and like it's small enough that it's simpler than doing. So let's say sum of map plus file of index up to index plus len minus 1. What do you think? Is this gonna type check? No, of course not. Okay, now it does. The problem is we don't want to score the entire list. We want to score each item in the list and then add up the results. So let's first confirm that like my score function even makes sense. Score the file at 0 of... Oh, this is wrong. Okay, I forgot what the function for checksumming is anyway. Great, so don't bother testing that function. It's wrong. It's times file, right? Over here. Why don't I just say file times this sum? There we go. So, okay, let me double check what how the checksumming works. Disk map, blah, 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 blah. The checksum. The result of multiplying each block with the block's position, which starts at index and goes to index minus 1. And we could multiply them each by file and then add them up, but it's equivalent to add them up and then multiply the result by file. That looks okay. Wait, the numbers were way bigger before, weren't they? Uh-oh. I broke part 1? I haven't touched part 1. Oh, no. Also, part 2 is so... Oh, no. It's still pointing at the test input file. There we go. Yes, that's the same input I got for part 1 before. So, is this the right input for part 2? It's the right answer on the first try, sort of, modulo a million non-compiling programs. But the first one that compiled, and that I thought might be right, was right. The second one, because the first one was reading the wrong file. Okay. So let's get rid of this debug thing. I really, these triples of ints are so bad. I really should give them a name. Okay, let's not do that today. First, let's get something working committed. Score int. Anything else you're upset about? Yeah. Part 2. Okay, there's a number of things I should fix, huh? Okay. This we don't actually need, although it is kind of nice to have. I don't ever make an array. I don't ever call freeze. What else? Part 2 needs a type signature, and score is wrong. Well, I have a different function, an internal function named score as part of part 1. Whoops. Fine. I'll leave that. Well, it's certainly been an adventure in ST and arrays and heaps. But it was fun to have that adventure, I guess. And in particular, like thinking of an efficient algorithm, reasonably efficient anyway, much more efficient than just scanning from both sides in or something horrible like that. Which, as I said at the beginning of all this mess, would have been efficient enough. But I had this idea for something that was more efficient, and I wanted to try it. I don't know if we can avoid reading 5 to 10 or 5 to 9, 1 to 9, but on average 5. Heaps at the beginning of each file move. It seems like you should be able to do better, but I couldn't think of a way. Anyway, that's definitely it for today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.